now. All right. So we've all heard about these things called containers. Now there's shipping containers. There's these containers that you can buy at a container store nowadays. But what are these things called containers? Ali, how would you describe that to somebody who doesn't have any exposure to what these things called containers are?
Sorry, did you call out my name?
I sure did.
All right, yeah, sure. Containers are an encapsulation of AVM binaries, and they allow for and they abstract away the binaries so that a set of services can be containerized. And as such, actually, sorry, my Skype is acting up here. Can you guys hear me?
Loud and clear. Keep on going.
Okay. Yeah, so there are two parts to the container, right? One is the image, and the other is a container that is running that said image. Containers provide consistency, and they allow control of the set binaries or code that is running within it back to the developers, and can be deployed out over different architectures, different OSs, and among others. So that at a high level is what it's basically the image and the set the binary that is running or the service that's running it is the container.
Gotcha. So, Tommy, tell me a little bit more about containers. What's been your experience? How would you explain that to somebody who's not had any exposure to them? And maybe answer the question, why should I care about them? Why do I even need them? What's the value of containers nowadays?
Cool. Good question. Because the one thing that you said that I want to key on is you were talking about there's different types of containers. There's storage containers, shipping containers. Well, just like storage containers, it wasn't just the container itself that made it so popular. It was the standardization. And once we had that standardization of we knew how to ship goods from one place to the other, it opened up all these new ways of transporting goods. And containers, Docker containers, kind of do the same thing. They have provided a way for us to standardize how we build these running applications and how we package them so that we can move them easily from our laptop to development to testing to production. So going back to why should you care about them? I mean, that's one of the many benefits of that is that portability that you get.
So it's not specific to a workload or to a specific OS. It's agnostic. Is that what you're saying?
So we've got Windows containers, we've got Linux containers. You can run IIS in a container, you can run MySQL, Postgres, WordPress, your own PHP, Java application. These are all the different types that we see containers in.
All right, so why the buzz now? I mean, either one of you, why is this so popular now? Why are containers the bright, shiny object all of a sudden?
So how about this? I'll talk about the dev side because I've got that dev background, and Ali can talk about the operation side. So funny enough, if you look and kind of trace the lineage of it, the concept for containers goes all the way back to the 70s, where those white papers that talked about having these isolated run spaces. And containers have actually been around since 2008. For those keeping track, that was actually before Obama was president. So they've been around for a while, but it was Docker that really made them palpable, that made them into a developer and operations friendly packaging environment. And developers, as a developer, I've always wanted to be able to take my application, run it locally, kind of run it in a box. But I've had a barrier to do that because I'd have to spin up a VM, and I have to spin up a VM for every component, my database, my application, maybe anything else it talks to. With containers, I can do that a lot easier because now I can spin all these up on my laptop without the overhead of 4 gigabytes of memory per VM. And so you get a lot more density when you start running containers.
Yeah, and once we as a community have decided that we are going to be utilizing containers to deploy and manage our applications, the next step to that is being able to manage containers at large, at scale, across platforms, and both on-prem as well as in the cloud, and across cloud providers as well. And that's where the need of an orchestrator comes in. And there are a number of them. Dating back to 2009 with DCOS, Kubernetes most recently, as well as Docker Swarm, and as such, we'll talk a little bit about Kubernetes as well. But that's where Kubernetes and orchestration fits in.
So both of you mentioned Docker. That's a pair of pants to me. What's Docker? Is it a company? Is it a technology? What is it? How do I use it? Help me understand that.
Sure. So Docker is at the heart of it, containers are a technology, and they're a way of isolating your applications and isolating your processes. Well, this had been, as I mentioned, around for a while, but it was Docker, the company, that came and made this into a more development-friendly, they were the ones that came and packaged it all and made it into a nice, easily to digest and easily to use format. So they've kind of become synonymous with containers. There are other ways to run containers, other implementations of them, but Docker has the lion's share of that.
Yeah, and that's in part and parcel to the fact that they have abstracted the API and made it available in such a way that it is agnostic to any platform or any OS, and it came at the right time when we had already been consuming virtualization was mature enough where we can take the next step into virtualizing above the OS as well. So it's not so much as what the technology that they came up with it's just the timing was perfect when it hit the market.
So then, is Kubernetes, is that another company? Is that a competitor? I had somebody ask me if that was an Uber that runs on kryptonite. What is that? How do I use it?
Kubernetes is the management plane on which Docker containers and others as well get deployed on and get managed on. So think of it from a perspective. Let's say that you have an application, .NET, Java, Python, any application that you have written and it's ready for prime time, and you will want to get it deployed at a massive scale. So what Kubernetes provides is it provides scaling of that container image, not only just the scaling portion of it, but also provides plugins or native support into one of the cloud providers as well. So there's a concept you can create services around it, and what that'll do is it'll create DNS entries, it will create load balancers in your choice of cloud provider, and manage all of that for you at scale, so that you can manage thousands of containers and applications all within the same infrastructure that is behind the Kubernetes application.
Interesting. Go ahead, please.
So once you start using containers, you start realizing you've got a whole bunch of them. They start to multiply. They're almost like gremlins or Mogwai, where they start getting bigger and bigger and more of them. And one of the things is you now have a lot more moving parts. So a container orchestrator is what they're called, helps you manage and orchestrate those moving parts. And Kubernetes is the most popular one. And also it's not a company. It was actually started as an open source project and then has been since then bundled into the Cloud Native Compute Foundation.
Interesting. So if these have been around for this long, well, let's start with you, Tommy. Give me an example of like a solution you did using this technology. Where can I take and apply this today to what I'm doing?
Oh, that's a great question. So it kind of depends on where you might be, like your role in the company. Mm-hmm. But I'll come from my perspective. As an application developer, I had a Python application that we were going through and scanning network assets. Well, I was doing this, but then whenever I wanted to deploy it, I found it was really difficult to go and spin up a VM that had to be nearby. And I found that with containers, I was able to do this on my desktop, verify that this works before I start checking in my code and pushing this to production. Because once it's checking my code, it kicks off the build, and that might be like an hour or so. But this, I'm able to have this kind of instant feedback of what my application looks like in production.
Interesting. So is this like an evolution of, the way it used to be? I need to do dev and test on my own. I did it on my own laptop or desktop in an isolated environment and went through all the complexities of that. Is this like the natural evolution of that, or is it something different? Or is that a different type of use case?
So that is one of the many use cases. Think about how we had old mainframes, that if you wanted to do development, you had to go to the mainframe, sit there, type it away. And then virtualization came around, and oh my gosh, this was a brand new space and allowed people to spin up multiple instances. But they were still not always on their local desktop, or they're not always as easily accessible. Now we've got like another revolution that's happening with containers. We're able to bring that closer to the developer so that we're able to have this tighter feedback loop.
And I'll just add to that, Tommy, from an operations perspective and an SRE perspective, if you had applications deployed on VMs and on different distributions across, even within Linux, and never mind between Linux and Windows, you had to do the patch management on that, and that was an obstacle in being able to coordinate the cycles around patching. Whereas in now, what you do is as a developer, Tommy can develop the application and containerize it. And me, from an orchestration perspective, it gets deployed on top of Kubernetes. And as such, the infrastructure that is underneath the Kubernetes application is not unique to any one application or the other. I can swap nodes in and out into my from my cluster, patch them, and then move on to the next. So as in, it's no longer it makes patch management a lot easier as well. Not just patch management, but any compliance or any other applications or that are running on your infrastructure much more easier.
And this is perfect because one of the things as the developer, you very often you write your code, you test it, and then you pass it off you kick it over the wall to the operations side. And the operations side gets this code and it doesn't work for them. And so then there's back and forth, kind of this blame game. Well, with containers, you actually add like this level of like almost a contract of say, hey, look, I've developed this in a container. I'm now can pass this off to operations. And they have a lot more assurance that this is going to run the same way as it does locally.
Yeah. And
oh, go ahead, sir. Go ahead.
No, I was just going to add to that, and that's not just important from a code perspective, but also from a configuration perspective.
Yep.
As well as binaries that are needed for that code and configuration. No longer will I need to hear or go back to Tommy and ask him, hey, why isn't this binary there, or why isn't this configuration there, or why is it different than what it was before. All of that is packaged up as an image that has been forwarded to me and an operations team, and I can just run from that. As long as it is executable, it is going to be run on Kubernetes as well.
Great. Hey, just a reminder to our listening audience, lines are open. Anyone have any questions they want to ask right now before I continue with what I have?
Yes, I have a question.
Sure. Who are you and where are you from?
This is Eric Huggins. I'm from a regional partner in South Bend, Indiana.
Welcome. Welcome. What's your question?
Well, I just wanted to make sure that I understand containers the way it's been described. The way that I understand containers, aside from the fact that it's a natural extension from servers to virtual machines to now virtualization without the OS. But the difference, the way that I understand it, is that if you think of the way you build containers, you're kind of compiling the container, and you have this object that doesn't change, just like our code that we deploy doesn't change when we're creating, say, a NuGet package. So we're creating a container that is both the code and the pieces of the connectivity to the operating system, that when I test it on my laptop, and then get ready to pass it off to test production, it's the exact same piece of binary as it moves between systems as if it were compiled, so that it's unchanging. And that if I need to change it, I have to recompile it. Is that an accurate description, at a really high level of the way containers are working?
So yes, let me add a little bit more clarification to help enlighten this. When you there's what's called a Docker file, and the Docker file is like a manifest, and it says run this, like start here. This is my base image. Then do this. Then do this. Then do this. Then do this. Then do that. And so each one of those, that's those layers you were talking about. Each time you run a command, it adds a layer on top of it, and that layer is really just a diff of what's the file system changes between that, and then another layer, and then another layer, and then another layer, another layer. And so when you get to the bottom of it, and you're at your last layer, that's your image. And this is what you can then go and move around from the different environments.
Right. Is essentially the Docker file the source code that I store in source control, and that the thing that makes the Docker container is using that source code to then create the object that I move around between environments? In that sense, is it very much like compiling binaries that get shipped into production in different areas?
Sure, it's a different type of binary, but it is a image for that container that the Docker file, when you're ever all said and done, that's that artifact, and that's what you end up moving around.
So then, from a DevOps perspective, now I'm actually moving exactly the same VM that contains exactly the same binaries from laptop to my dev environment to the production environment that might be running on Kubernetes, right?
Correct. And you store that in what's called a registry, and a container registry, which is the place that you store all those.
Now,
and you can pull it down.
Now, one of the things that I've been wanting to do I use VSTS for all of our builds, and one of the things that's frustrating for my developers is that I typically use Dev Test Labs to turn VMs on and off to save money when so they're only on during working hours, and sometimes we don't know that we're going to be working on them, so they don't automatically start up. A developer goes to deploy and test something, and the VM's not started, and then I get an email that says, "Why doesn't it work?" And it's like, "Well, did you check to see?" Is there an advantage to using containers where it would be quick to start and stop and create and these different environments as we're testing code?
So what you can do is there is a service called ACI, and to answer your question, yes. So what you can do is, instead of having your pipeline be implemented on VMs, you can actually containerize your code. You can include your binaries. You can include your binaries inside of a container, write a Docker file that incorporates your compiled binaries, and all of this can be front-ended by a CI/CD, like you mentioned, VSTS. And instead of being executed on a VM, you can execute it on ACI. Now there are ways, and I can forward this to you, but essentially your runtime is going to be on an ACI, and once you're done with that, you can kill your ACI and be done with it, and not have to worry about your dev test VMs being available or not available and such. And the ACI, you get charged by the second anyways, so you don't have to worry about it from that.
So then would the containers then be available once I got done with it in the test environment running against ACI? If my production container environment were in Kubernetes, would I be able to deploy the same thing that I deployed to ACI to Kubernetes?
So when you talk about the same thing, it's the same image. ACI
Right.
takes an image and deploys it for you, and Kubernetes will take that same image and deploy it for you. So when you talk about if it's the same thing, yes, in essence, it's the same thing, but it's not. It's the same implementation of an image.
Right. I don't have to run the compile program again to create a new image. It's the it's making a copy of something, so they're all exactly stamped duplicates.
That's right.
Is it faster to start a container than it is to start a VM?
Much.
Magnitudes of
Magnitudes. I mean, that's one of the struggles I have, and I've played around with the idea of creating a PowerShell or even an Azure function that would start and stop a VM. But my issue was, well, that could take 10 minutes to get everything all ready and operational, but containers would be faster.
Yes. So it will take you seconds to deploy an ACI, an image into ACI, as opposed to, depending on the size, the SKU that you choose and the region that you choose, it'll take you a few minutes.
Okay.
And funny enough, I saw some statistics about performance just the other day. And if you're doing, say, a Node.js app in Windows Nano Server, the Windows Server container will start up in under 600 milliseconds, while a VM will take a good bit longer.
Yeah, and I think, Jeff, you talked a little bit about the use case. If you guys have used the Cloud Shell, both the PowerShell as well as Bash implementations are on containers.
Right, from the Azure portal, right?
That's right.
Excellent. Eric, thank you for your questions. Anybody else there interested in joining us on open mic here while we got the lines open?
Yeah, I do. Hi, this is Bryant.
Hey, welcome. Thanks, Bryant.
Hey, I got a quick question to ask you. So I'm more from the IT side, but I know that there are some containers out there already, whether it's for Ubiquity has one for their cloud app, for their controller software. Does Azure support the ability to actually just run containers, or do I need to spin up a VM and throw my container into a VM?
You can. There are a number of ways that you can do so. To answer your question, yes, you can just run a container. Azure Container Instance is one method through which you can do it. There are app service for Linux, which also does the exact same thing, which is takes an image from your Docker image, and then it deploys an app for you. So those are just two ways, and not even have to worry about Kubernetes or Orchestrator or any of that. Just straight, you have an image that you've tested on your laptop, or has been made available by an ISV that you mentioned or any other, and just take that image and deploy it from there.
Gotcha. A second question. So because they are containers or containerized, when it comes to doing updates, do I need to basically down the container, export the data, and import the data into a new container if they haven't upgraded or version upgrade?
So containers get deployed from an image. So if you update that image, you would have to basically kill that. That's where the orchestration piece comes in. It will be much easier, or there's a mechanism and a process through which that will be done on an orchestrator, i.e. Kubernetes. But if you're using ACI or app service, then you will have to do that manually.
Gotcha. Okay. And I kind of joined the call late. You talk about these Cupertini and the app. What are those?
That Kubernetes is the orchestrator. So once let's say that you have deployed an application on a container, and your colleagues within your enterprise have thousands of different applications, all made containerized. They need to be managed at not just from an deployment perspective, but also scaling and updating, and all of those are services that an orchestrator provides, or features with it that an orchestrator provides. So Kubernetes is just one of the orchestrator out there. There are others, but I would argue it probably has the most momentum behind it. And as such, there's a lot of investment being made by Microsoft when it comes to the development of services that support Kubernetes and Kubernetes in general as well.
Okay, good. I guess for me is I'm just trying to think. It sounds like a great idea, but I'm just thinking in terms of IT, so the system side. If I need to do updates, if there's an ISV who has a container, and they do an update, I guess there would be some orchestration involved to get the container updated. I assume, correct?
When you talk about update, are you talking about update as in update to the underlying OS binaries, or update to the actual code that is being that is facilitating the application?
Oh, good question. I guess in this case, it's probably just to be the binaries themselves.
Okay, so then in that case, yes, you would have to rebuild the container. But if let's say that you had to patch an OS binary or something, you can actually take a node that is within the cluster out, patch it, and then bring that back in. And the orchestrator will do the taking will do the orchestration piece, i.e., take containers off of that node and then put it back on once it's back into the cluster.
So actually, I'm glad you mentioned that. So the second piece is, let's say that Azure allows me to run containers straight off. I can containerize it. So if I bring the container over, do I need to worry about the backend to patching, or is that handled by Azure?
No, so that's done by Azure. So if you use one of the PaaS services, i.e. Azure Container Instance, you don't need to worry about, and same goes for App Service for Linux. You don't need to worry about patching or any of those, or even scaling for that matter on the back end. But if you're using AKS, which is the managed Kubernetes service, then in that case, you would have to worry about the patching when it comes to your worker nodes, not on the master, because that is that is provided to you as a managed service.
Gotcha. And so let me confirm these two services. You said the one is called Azure Container, and what's the other one called?
Azure Container Instance is the service that basically will take your image, run it, and make it available to you. Now there are ways that you can make it externally available. There are configuration values that you can put to it. But that's one service. The other service is App Service for Linux, which does the same thing, but it is a evolved technology from web apps, which was one of the first services that Azure had.
Gotcha. And one last thing, off the top, do you know how much those services cost per month?
I think it's per second on the ACI, and there are different T-shirt sizes that you can use when it comes to ACI, and so I don't know off the top of my head on exactly per second how much it is, but I know it's per second on the ACI and different SKUs, and on the web apps it is by number of VMs that you pay. And I can post here, or as a follow-up, I'll include the links in terms of the pricing.
Yeah, that would. Cool. I think that would be good, because a lot of that varies based upon how you're buying and consuming Azure.
Gotcha. It almost seemed that if they're charging per second, I mean, I guess it's got to be pennies. It would be like 0.0001 cent. Otherwise, it would just be cheaper to spin up a VM. But I'm just curious. I just thought about that. That's why.
Yeah. So if you, as a use case, if you're going to ask me whether you should spin up an ACI instead of a VM for your regular compute, I would say no. Don't do that. What you can do is have a baseline on VMs. When I say VMs, you can use AKS or other services out there, and then burst into ACI when needed. And there are native tools for Kubernetes that you wouldn't need. Like all the setup is there done for you already. So if you want that functionality, just deploy that ACI connector, is called, inside your Kubernetes cluster, and from there on, and whenever your application needs more load than the baseline VMs it has allocated, it will burst into ACI.
And as a kind of follow-up to that, I don't have the exact numbers in front of me as well, but it is more expensive to do it in ACI. And I think they said if you do ACI for one container with one core for a full month, it's going to be about $60, which you can get a one-core VM for less than that for the whole month.
Okay, cool. Excellent. Thanks.
Brian, thank you. Appreciate your line of dialogue there. Anyone else?
To follow up on the app service for Linux, what limitations are there on the type of containers that can be deployed there, other than that they have to be Linux containers?
I think there are some port limitations, but short of that, the same thing. It's just a different methodology through which it's being deployed. It's an added service to an already existing service, whereas an ACI is a net new implementation altogether.
And that
So
might
early
be
on,
a cost affordable. That might be a cost-effective way to deploy containers is to use the app service for Linux in some cases.
I wouldn't look at it that way. What I would look at it is how familiar are you with using containers and app service. If app service is something that you're familiar with and know how to use, then that would just, Linux workloads. To deploy a Linux workload into app service, that's the mechanism to do so. But if you are more interested in just and are familiar with using containers and just want to be able to deploy them, then ACI is probably the most efficient way to test your code and develop your application. But when it comes time to actually running it, then look for something like AKS and others.
Okay, thanks. That makes sense.
I have a question from the IM window here. Saul is asking, is there a use case for containers for infrastructure, servers like DCs, DNS, file servers, RDS, etc.? What's your thoughts there?
So from an operations perspective, yes, from an infrastructure, not. So there is a concept of persistent state within containers. Generally, up until very recently, those were not the type of workloads that should be utilized within containers. But with evolving technology, you can do so now. So you can have Azure, you can have a container backed by one of the persistent technologies, whether it's AWS's or ours, and hold state of that application in that technology. So yes, you can now. It's still cutting edge, bleeding edge, however you want to phrase it. But the more, I think the better use case for running containerized applications when it comes to an SRE implementation or operations is to execute repeatable processes. So for example, if you have a Puppet application, server, Puppet Master or Puppet Nodes or Chef or any of those that basically when a VM comes in, you want to be able to do a set number of tasks, or when a load balancer hits a set number of errors, do a predetermined set of things to troubleshoot. Those type of things, when you are reacting to an alert within your system, that can be containerized and run on any of the technologies that we're talking about. And that's probably a better use case and how it's currently being utilized, containers at large within these teams and practices.
And yeah, to follow up on what Ali said, the sweet spot for containers are these stateless processes. And I don't mean the stateless application, because almost every application has to maintain state, but where your state is stored external. As you mentioned, there are ways of storing the persistent data inside a container, but it is mounting it really into the container, but keeping it external to the container, because the containers intended to be ephemeral. They're intended to if it goes down, that's great. You want to treat them like cattle. The big cloud phase is to say, treat your applications like cattle, not like pets. Pets where you want to take care of them, make sure that they're loved and taken, and they're enjoyed, and that everything's taken care of. But more like cattle, where if something happens to it, you're able to kind of shoot it in the head and move right along and bring up a new one.
And I'll just say the exact same thing, but not just for apps, but even for infrastructure. So treat infrastructure like cattle as well, and not pets. That's what containers and the orchestrator that manage those containers provides.
Awesome. So any other questions? I've got a few others, but any other questions? All right.
If there's no questions, actually one thing I would like to mention is one of the announcements that maybe all of our partners aren't aware of, which is the managed Kubernetes service. Would this be a good time to plug that?
Plug it away.
All right. So as we've been talking about containers and orchestrators and Kubernetes, well, Kubernetes being the most popular orchestrator, one of the things that Microsoft has recently announced is called Managed Kubernetes. So when you have a container orchestrator, typically you have the master. The master is the one that will manage all the data, kind of store, hey, this is what container's running where, this one died, bring another one up, schedule all this. And then you have the agent nodes, and the agent nodes are where all your workloads are being run. And you have those separate because you don't want, if something breaks down your worker node, you don't want it to affect your master. Well, with Managed Kubernetes, AKS, we have now offered you don't need to manage the VMs for Kubernetes, and you only need to manage the agents. And the thing that not even Google does, because Google is the only other one that offers Managed Kubernetes at this time, is they charge you for use of the master, but we're providing that for free.
Wow. So hearing that in our previous discussions, I'm a partner and I've, maybe got an infrastructure practice, I've got an app dev practice, maybe I've gotten both. How do I make money on this? What do I do to turn this into something I can sell at customers and deliver value? Because it's very intriguing, but what's that next step? Tommy, what's your thoughts there?
So it's kind of interesting. I'll have to admit, Ali and I might have different opinions on this, but for me, containers are kind of really a means to an end. They allow you to ship and bundle and manage applications really easy. So my observation is that unless you're really in the container technology, like you're a company like Docker, Aqua, Microsoft, you probably aren't going to kind of quote unquote make money with containers. But here's the great part is since containers do allow you to ship and bundle and manage your application a lot easier, partners are very eager to embrace that because it allows them to increase their operations and dev productivity. Kind of going back to that, it's a means to an end. It allows them to be more productive and allow their developers to be more effective.
Okay, so would you say it's more like an evolution of how you've done things in the past? And what comes to mind for me is we used to do manual static IP addresses, then DHCP, and we used to build physical machines, and then we evolved to VMs. Is that something similar here?
I would take the word evolution to kind of make it even a little bit more dramatic and say this could be a revolution.
Oh, okay.
So yes, and even bigger.
Yeah, and I just want to add to that. It's what SIs or ISVs, doesn't really matter what type of partner you are. At the end of the day, each customer or anybody that has an application out there, what they're trying to achieve is elasticity. And what that means is they don't want to pay for what they're not consuming. And containers provide the ultimate means to achieve that, i.e., it doesn't matter where you're running, which cloud provider you're on-prem, you're on AWS, GCP, Azure. Once you containerize your applications, you can run it in exactly the same way regardless of which platform it's running on. So it accelerates how you can achieve elasticity on a platform.
Interesting. For folks in the audience, I'd be curious to hear your thoughts. Are any of you using this in your practices today? What have been your experiences? Once again, mic's open. Would love to hear from the audience.
Hi, this is Brian again. I got a quick question. I heard brief comments about persistent storage. With containers, there is storage, correct? There is persistent storage?
It's persistent to the host that container is running on at runtime. So if you have a cluster or if you have when you deployed that image, when you initiated that container, it is associated to that host. And that's not what we talk about when we talk about persistent volume. what the persistent volume means is that when you initiated that container, it is an external data source that you have incorporated or mounted into that container. So even if that container were to go down on that said host, the binaries or the volume will still persist. So if you were to recreate or that container on another node or another VM, it will still go out and mount that same external volume back into that container.
Got it. And that's the ideal case to always mount that data. And the reason why I bring this up is because there's an app that we want to use, and they have a Docker for it. And I'm thinking that's great, but then if I want to do the backups, it looks like I have to bring third-party storage. I have to introduce storage or mount some kind of third-party storage for backup. Then is that fair to say?
Yeah, it depends on what your application is doing, right? So if it is just processing, then I would say no, right? But if it is holding state as it relates to the application, then yes. And I think what you mean is database. Is that
Yes.
Correct? Yeah.
Correct. Yes. Exactly.
Yeah. So in that case, yes.
Perfect. Okay. Good. Thank you.
So Tommy, from your perspective, I'm listening to this conversation. I'm an app dev guy or gal. Where do I get started? What's your recommended path for me to get up to speed on this? You know, Microsoft produces tons of content, be it videos, blogs, the list goes on. You know, where do I get started? What's your thoughts?
So I'll have to admit, it is pretty overwhelming to get started from nothing. But there are some really cool guidelines I've found. I myself am working on a set of workshops for getting from zero to hero for containers as well as Kubernetes. That said, there is a website called Play with Docker. I believe it's play-with with docker.com. And that will actually kind of give you this click-through guide, and you actually get a chance to type in these commands into a VM that already has Docker installed in your browser. Katacoda is another really great online website that has some walkthroughs, and you click the button, or you click where the command is, it types that into the prompt, and it hits enter for you, so you don't even have to like type too much. You just can click through and see what it does. And then if you say, well, wait a minute, let me try this different command, you can still do that. So you get this kind of interactive terminal with Docker to play with in your browser.
Awesome.
And for Kubernetes, if you are comfortable enough now, once you go down the journey of learning about containers, Kubernetes themselves, I think they have an interactive guide tutorial that will allow you to go through each of these steps and utilize all of the native kubectl commands and learn from there. So I would suggest just Kubernetes official documentation is the best place to start off.
Okay.
Ooh, and one more I want to throw in there is one called Minikube, Minikube, and it's a way to run Kubernetes on your laptop. It's just a one node VM, but you can run it from your laptop and play around with Kubernetes that way.
Great, and we'll make sure we capture all these links and post them to the Yammer group for those who weren't able to jot them all down quick enough. So one last question that I have, and it's a two-part question. Why are containers important to Microsoft, and why do containers on Azure? Ali, what's your closing thoughts on that?
So why are containers important to Microsoft? Because they are relevant in the marketplace. So as a cloud provider at large, we have to supplement the technology that is resonating within not only the tech community but just technology in general. So that's my answer to why Microsoft should embrace containers. And as it relates to the investments made in how Microsoft is putting its own flavor on containers, that's primarily coming in the Kubernetes space, and the new services that are being offered that are right now only available on the Azure platform, like the managed Kubernetes service that was recently announced.
Okay, Tommy, your perspective.
All right, so just want to make sure I got the two questions. It was why are containers important to Microsoft, and what was the second one?
Why Azure? Why do this on Azure versus any other cloud provider?
Okay. So as I mentioned from my possibly dramatic statement, that I don't believe this is just an evolution. This is kind of a revolution of development and how we package and deploy our applications. So that being that Microsoft is a technology company that is at the heart, wants to empower developers and have you run. I mean, our logo, one of our mantras is any app, anywhere. And Docker's is, being able to run any application anywhere. So those two are just hand in hand. And why Azure? Well, we've done a lot of work. Again, Microsoft is a company that's been entrenched with developers for decades. And we've even hired one of the founders of Kubernetes, Brendan Burns. He is here to help make our and kind of cultivate our container story inside Microsoft. So we've got some of the top people. We really do. And I'm really excited for where containers are in Azure and upcoming announcements.
Interesting. That's a very compelling piece of information about who we hired and what we're doing with them within the organization. So that really highlights our commitment there. So great insight, great perspective. Well, are there any last questions from the audience? We've got just about a minute left before I want to wrap things up. Anyone got a short question before we come to the adjournment of the call?
I think that.
Go ahead.
Yeah. No, yeah, that's exactly what I was going to refer to. There's a question around the websites, and like Jeff, you mentioned, we'll gather those and send it out. And there was a follow-up question here in terms of being able to deploy density containers, providing the mechanism through which you can deploy applications at density on VMs. And yes, it does. And you can scale that up or down vertically on VMs that are running your application or running Kubernetes, or you can horizontally scale out and add more nodes to supplement the containers that are running on top of Kubernetes.
Yeah, I posted that as a response to Jeff's question: is why is it important to Microsoft? I think it's not only to support the movement in the development community, but from a pure infrastructure standpoint. The reason that we're starting to see containers show up as in the Linux space, on the function side, a number of places in Azure is because Microsoft can provide more services without having to add more infrastructure the more containers are used, because there's a higher density involved. So that's the benefit to Microsoft. Use more containers, get more workloads, less infrastructure.
I like the way that sounds. That's a good deal.
Yes.
Awesome.
Nice summary.
Yeah. So on that note, we're going to wrap up the call. I'd like to thank everyone for joining. Next month, we'll have a very similar call, but our topic will be serverless. So expect some blogs from our team coming out mid-month, followed up by, once again, a community call. I believe the date is December 15th at 1 o'clock. It's already posted in the landing page. So we'll make sure this recording gets into Yammer. You'll have references to all the links that we talked about during the call here. And in not too distant future, we're also going to be posting this on YouTube. So as soon as our channel is set up, we'll be able to we'll announce that, and you'll be able to subscribe to us with on YouTube. So thank you for everyone. Ali, Tommy, thank you for your time. Appreciate you stepping up here and talking about these things called containers. I now know I don't have to go to the container store to get them. This is a good thing. And all righty, everyone. Well, for those in the United States, have a great week next week. Happy Turkey Day. Happy Thanksgiving. And if you have any questions, comments, or feedback about this particular community call, drop us a note in the Yammer group. So thank you, everyone, for your time and attention. Let's adjourn the call, and we'll see you next month. Take care.
Thank you.
Bye-bye.